Hello and welcome to our lesson on quadratic functions. You should have a notes paper, and if you don't, you need to get one. Once again, just like always, you will need to show your notes paper to the teacher in order to receive the homework assignment. So please make sure you have that ready to go. Today, our objective is that the mathematicians, you all, can graph quadratic functions in the form of y equals ax squared plus bx plus c. So, some things that we need to understand to get started. In the quadratic function y equals ax squared plus bx plus c, the value of b directly affects the position of the axis of symmetry. So we've looked at parabolas a little bit here and know that there is always an axis of symmetry. And so that can be found from the equation with the letter b. Now you'll notice as you look at the graphs, the axis of symmetry is not exactly the number from b. So if, for example, in the first graph here, b is 2, but it says the axis of symmetry is -1/2. The b value in the second one is 4, but the axis of symmetry is -1. And the 6 here, and we have an axis of symmetry of -3/2. So how are we getting that axis of symmetry? Well, the axis of symmetry is coming from this. The graph of y equals ax squared plus bx plus c has the line x equals -b/2a as its axis of symmetry. So this formula right here is going to be key to helping us find our axis of symmetry. Our axis of symmetry is also going to include the vertex, and that will always be the case. So this is also the x-coordinate of the vertex, and then we will have to use that in order to find the y-coordinate of our vertex. But that -b/2a is how we are finding the axis of symmetry. So if you take a look, just to go back a slide here and just, peek at that, -b/2a was that formula. So b is here, so -2/2 times the a value, which was 2. This equals -2/4, which does equal -1/2 for that first one there. So just as an example, that is how you can find that axis of symmetry. All right, so let's go ahead and move on here to problem 1. What is the graph of the function y equals x squared minus 6x plus 4? We do need to start off by finding the axis of symmetry, and part of the reason for that is it also helps us find part of the vertex, or the x-coordinate of the vertex. So I'm still thinking of -b/2a. Negative, and b in this case is also a negative, so I'm just going to use parentheses so that I don't confuse myself. And then 2 times my a value. Well, my a value in this case is 1, so now I've got +6 divided by 2, which is 3. So as I look at that there, that is going to be my axis of symmetry where x is equal to 3. So if I just kind of keep that in my mind, on the x equals 3, this should be my axis of symmetry. Okay, so how do I continue? Well, I can now take that x value that I know, x equals 3, and plug it back into my equation. Y equals 3 squared minus 6 times 3 plus 4, and that will give me the y value, or my y coordinate for my axis of symmetry. So I've got 9 minus 18 plus 4. Nine minus 18, and add 4 gives me -5. So I now know that for my vertex specifically, I have x equals 3, y equals -5, so I am looking at the coordinate 3, -5. So over 3, 1, 2, 3, 4, 5, this is my vertex. Now, as I take a look, I am going to have to erase some of my work here because now I need to find more points to be able to graph this quadratic. So one of the ways that I can do this is by choosing another x value and substituting it in to find a y value. So I am going to choose the x value of 1. And I'm going to plug that in. So y equals 1 squared minus 6 times 1 plus 4. 1 minus 6 plus 4. Well, 1 minus 6 is negative 5. Negative 5 plus 4 is negative 1. So my x was 1, my y is negative 1 in that case. So 1, negative 1 is a point on this parabola. Now I know that parabolas are usually shaped like a U, and so I'm going to choose something that I think will help me out here. And when I'm doing that, again, this is my axis of symmetry, so I'm going to be thoughtful as I choose my next x value to plug in. If this is my axis of symmetry, then I am going to guess that my other point would be right around here, or really it should be there. So I'm going to try plugging in x equals 5. Y equals 5 squared minus 6 times 5 plus 4. 25 minus 30 plus 4. Negative 5 plus 4, and again with negative 1. So 5, negative 1 is in fact my other part of my parabola. I am going to see if I can get some more points up here on the top so that I have a more accurate parabola. And so I am going to try plugging in x equals 0. Y equals 0 squared minus 6 times 0 plus 4. And that leaves me with 4. So 1, 2, 3, 4. And again, because of my axis of symmetry, my other point should be right here. So I now have a pretty good idea of what my parabola looks like. So some things to be aware of. On this parabola, you will notice that this is a minimum down here, that we have a minimum value. And one of the ways that I can tell that as I start my problem is by looking at my coefficient here at the front. If my coefficient is positive to my squared term, then my parabola is going to open upwards and my vertex is going to be a minimum value. If the value with the squared term is a negative value, then my parabola would in fact open downward. And again, it could be wide, it could be skinny, but that parabola will open downward and my vertex then would be my maximum, the highest point. So go ahead and try the got it question. Go ahead and pause the video, give it a try. When you are ready to check your answer, please resume the video. All right, welcome back. Go ahead and check out your answer here. Hopefully you noticed that in the original equation, the coefficient of the squared term is negative, so that should have told you right off the bat that this was opening downward and that your vertex was a maximum value. All right, let's continue on. We have a quick reflection question. In problem 1, why do you think it's useful to use the y-intercept as a point on the graph? So again, if you could pause and take a moment to reflect on this question, and then when you are ready to check your thoughts, resume the video. All right, welcome back. So in problem 1 and on graphing parabolas in general, it is sometimes and most of the time useful to use the y-intercept because it is extremely easy to plug in x equals 0. And so whenever you have a y-intercept, that is where x equals 0, and so that just allows us to have an easy way of solving the quadratic in order to find some points on the graph for it. So that's just kind of something that you'll catch on to over time, but plugging in x equals 0 to find the y-intercept is always an easy place to start finding points on your parabola. All right, so let's take a look here at problem 2. We are going to be looking at vertical motion here. During halftime of a basketball game, a slingshot launches t-shirts into the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? What is the maximum height? And what is the range of the function that models the height of the t-shirt over time? So lots of information here. We've got 72 feet per second and 35 feet. I noticed that I am going to be finding the maximum height, which does tell me that if I was graphing this, that my parabola would open facing downward. So I need to start off by writing an equation somehow. So if you think back to 9.1, our previous lesson, we had the height of a falling object using the formula h equals negative 16t squared plus c, where c was our initial height and t was the time. And so if I need to add velocity into that, which in this particular problem I do since it gives me that in the problem, I change that formula to negative 16t squared plus vt plus c. So I have that velocity there in the middle, v for velocity. So with that formula and with the values given in my problem, I can figure that out. I do see in my diagram here that I have the measurement of 5, so I do believe that my initial value is 5. So, sorry about that. So, as I look at this, negative 16t squared plus the velocity is 72, so 72t plus the initial value of 5. So there is my equation here. So I need to first figure out the axis of symmetry, or figure out the t value. So I'm thinking about negative b over 2a. And in order to do that, I need to plug in negative 72 over 2 times 16. Well, I know that 2 times 16 is 32. And 72 divided by 32 is 2.25. And I see that I have a negative and a positive, so I've got negative 2.25 as my value here for my t. I'm sorry, I missed a negative. That was supposed to be a negative 16. Good thing I was double checking my work there. So negative 16, which means my answer is actually positive. I apologize for that. So now that I know that my t is 2.25, I need to plug that in for t to figure out my height, or my maximum height. I did just find that t equals 2.25, so that means my time, and I'm going to write that over here on the bottom left, my time is 2.25 seconds. So that is how long it takes the shirt to reach the maximum height, just over 2 seconds. So I do need to erase a little bit, give myself some space. So now I need to plug 2.25 in for t. So negative 16 times 2.25 squared plus 72 times 2.25 plus 5. So go ahead and take a look here at the Got It. Once again, pause your video, give it a try. When you are ready to check your answer, please resume the video and I will show you the answer. All right, welcome back. For this particular question, the time that it took is only 2 seconds. The maximum height is 69 feet. Therefore, my range of height is 5 is less than or equal to h is less than or equal to 69. So it can be anywhere from 5 to 69 feet at any given time. So today, that is it. So if you would please, once again, make sure you show the notes page to the teacher to receive the homework assignment. That would be great.